Welcome back, everyone. In this lecture, we're going to go over the solutions for the PyTorch Basics exercises. Let's get started. Okay, here we are at the exercise notebook. First thing we're going to do is go ahead and import torch, and then import numpy as np. Then we'll go ahead and set the random seed for numpy and PyTorch both to 42. So we can do this by saying np.random.seed to 42, and we'll do the same for torch with manual seed to 42. Okay, so keep in mind if you don't want to see this output generator line, you can simply add a semicolon. Either way is fine. Then we want to create a numpy array called ARR for array, and then we want it to contain 6 random integers between 0 and 5. So let's go ahead and do that. We'll say np.random.randint, go from 0 to 5, and then we want 6 of those. So if I take a look at ARR, it's 3, 4, 2, 4, 4, 1. And if you're getting a different set of numbers, go ahead and rerun your random seed cells. Next, we want to create a tensor x from the array above. So let's go ahead and do that. We'll say x is equal to torch, and we'll go ahead and just use from numpy, ARR, and then go ahead and take a look at x. It should be now as a PyTorch tensor. Then we want to change the data type of x from integer 32-bit to integer 64-bit. So recall we can do that by saying x.type and then reassigning its original. So we'll say torch.integer 64. And if you take a look at x, you'll notice it won't actually report back if you just say x now. But let's go ahead and take a look at x, and then we'll call type here. Whoops, make sure we call type with parentheses, and it will report back long tensor, so that kind of also confirms it. But you can also call dtype, and it'll report back that it's integer 64-bit. So 2 different ways to check that, since integer 64-bit is also called a long tensor. Okay, next we wanted to reshape x into a 3x2. Several ways you could have done this. You can use resize, reshape, or view. Again, kind of totally up to you. We'll go ahead and say x is equal to x reshape 3x2. Let's go ahead and show x after that, and now it's a 3x2. Next, we wanted to return the right-hand column of tensor x, and recall we want it actually as a column format, so we're going to have to use slice notation, not just index notation. So if you just say colon, comma 1, you'll get back the values. In order to actually get the column in its original column format, you have to do that slice, and then that returns back that right-hand column. Then, without changing x, return a tensor of square values of x. So lots of different ways to do this. You can check out the solutions notebook for a myriad of ways, but one way to get the square is simply by taking x and then getting the square of everything, so to the power of 2 for all that. Or you can just simply say x times x, which is going to be the same thing. And there's a couple other ways you could do this. They're all shown in the solutions notebook, but lots of different ways to get that square values. And the reason we don't want to reassign it is because we're going to use the same original x in part 9s and 10. So for 9, we wanted to create a tensor y with the same number of elements as x that can be matrix multiplied with x. So what we're going to do here is we want to think about the shape it should have to permit a matrix multiplication. So we'll say y is equal to torch rand int, and we'll say 0 to 5, and then what we want to do here is pass in the shape. So you can either say 6 and then reshape y, or if you take a look at rand n, you can actually specify the size or shape there. So it's up to you if you want to say 6 here and then call reshape off of this, or if you want to pass in as a tuple the size directly. And in order for a 3x2 to be multiplied by this tensor, what we want to do is have it be a 2x3. So then what we're going to do here is we'll go ahead and show you what y looks like. It's this tensor, and don't worry too much if you didn't get the exact same random integer values. That doesn't matter as long as you got the same shape, a 2x3, because then we want the matrix product of x and y, which is going to be x dot mm y. And then you get back this result. And again, if you're getting back different random numbers, that doesn't matter too much as long as you understood the basic idea that the number of columns in X needs to match the number of rows in Y. Okay, so that's it for the PyTorch Basics exercises. Coming up in the next section, we're going to take these basic concepts of tensors and then apply them to actually building out full neural networks. I'll see you at the next lecture.